from common source of unwanted alarms. Reliable flame detection, immunity, operator immediate visual identification. No need to send personnel into hazard, visual confirm the alarm. Operator able to identify risk and improve response. Smoke detection, that's another, we use smoke detection. Mostly smoke detector is used in electrical room, in electrical control rooms. We use a lot of smoke detection system. And we use different type optical. Lately they're using a high sensitive type smoke detector. They call the Vista unit. We'll go over that. Gas detection, we use a lot of gas detection because of the flammability. We do use gas detection. The Calic beat, that's old now. Basically most of our gas detectors IR energy absorption type is a point or open path. We'll go over it when I show the slides on this. Infrared gas detection is based on a unique IR absorption pattern associated with the SU gas and vapor. First used on the offshore installation early 1990. Early technology had problem with stability, alignment, optical interferences. Based on offshore experience, IR gas detection, third generation technology are now more reliable. That's what I was just talking about for the purpose. Theory of operation, practical implementation, open gas detector are capable of measuring gas in a space rather than a single point. Clear line of sight, stable vibration-free mounting, clean optical surfaces, shielding from direct flared radiation, avoid access, path length. And this is a different type of, this is a gas detection. That's basically it's open path detectors. There's a transmitter and a receiver. I'll show it to you. That's basically how it works. And this is your gas detector, and this is your smoke. That's your flame detector, and that's your smoke detectors. Kind of general. Design basis is in a course hazard assessment, which document the significant fire and gas-related hazard, specification of fire gas detection requirements in terms of hazard size, response time, control actions, availability, and record of special operation requirements. So, these are the next. Yeah.
So if you have a smoke, you can get it from the smoke, right? Then you can put the water or whatever the smoke is. Something like that. Fire, right?
Right.
What can you do? You find the gas leaching.
We put a gas detector in the control. We put smoke detectors in the electrical and control rooms. And what we have is we also have when there is a smoke coming, obviously we shut down the HVAC system. Okay? And normally we don't provide suppression for electrical control room. We have fire extinguishers. We only shut down the HVAC system.
So if you're working the LNG room, you find LNG detection system as well.
The LNG coming from outside?
You have a tank in the room.
Electrical room, or are you talking about process area?
Process room.
A process room? Yeah, we don't put smoke detectors in a process room. No, we never put.
It's not smoke, it's just a cloud.
Like I say, in the process area, we put a lot of gas detectors, which measures the hydrocarbon gases. We do provide flame detectors and hydrocarbon gas detectors. Basically, that's what we have. And the gas detectors can detect any type of gas. Let's say if it's a methane, propane gas, they do measure that. So we do have gas detectors all around the process areas.
So if you detect a gas,
what we do, the HVAC raises. Like I said, normal operation, we have 6 air changes per hour.
okay.
Then when it detects a 25% LEL, we increase the capacity of their ventilation system to 12 air changes. Okay, you go higher ventilation. If that is a problem, again, the gas is still going up. Your LEL, instead of 25%, goes up to 60%. then we know there is some abnormal condition. Then we shut down your HVAC, we shut down, we blow down, and everything else goes with it. So
What do you do in the electrical area?
electrical, when we shut down it sooner, because electrical, if there is a gas coming, we put the gas detector at intake of air handling unit. Because it's anything coming from outside, as soon as we see a 25% LDL coming inside the electrical, we shut down HVAC system. Okay? This is a fire gas detection control system. Basically, fire gas detection system detects the fire and gas releases, interfaces with warning, process control, and suppression system. For NFPA 72, that's our Bible in NFPA 72 terms, it says fire alarm system, a system or portion of combination system that consists of components and circuits arranged to monitor and enunciate the status of fire alarm or supervisory signal initiating devices and to initiate the appropriate response to those signals. Fire gas detection, common terms, is a local panel, is a fire and gas control panel in a specific area that controls logic for that area. Proprietary supervising station, a location to which alarm or supervisor signaling devices on proprietary fire alarm system are connected and where personnel are in attendance at all times to supervise operation and investigate signals. That's part of their code requirements. And if it is supervised, it says, what does that mean? It says to sense a condition needing attention and initiate correction action if necessary. Alarm, a warning of fire danger. Alarm signal is a signal indicating an emergency that requires immediate action, such as signal indicative of fire. Trouble signal, a signal initiated by the fire alarm system or device indicative of fault in a monitor circuit component. Common fire detection methods, some of them we talked about, smoke. We have two major detection methods, blockade, dispersion of light. We use photoelectric smoke detectors and also use ionization smoke detectors. Those are the two that we use in the North Slope. Advantages of inexpensive early detection, capable for smoldering fires, no need to a line of sight. Disadvantage, slow flame detection, indoor application only, false alarm from dust and fog. So those are kind of, this photoelectric are not that sensitive, but we do use them. There's a photoelectric smoke detector, the way it is a LED, produce a light in a special chamber where no smoke is present, and a high fills the chamber and absorbs by the chamber walls. The chamber is designed to keep out ambient light, but in smoke. Dye sensor for the diode view, so you can read that. That's nothing. Two types of early. Then we talking about this too early warning smoke detector. That's the one I was talking about. Aspiration. There's very high sensitive type smoke detectors in the market these days. They call it a Vesta unit, and those are all laser type and point type system. And basically, they use this in the control room. This aspiration detection system, you have your control panel, and here's your aspiration detector, and you have different rooms. You have a small pipe, maybe 3/4 inch of tubing goes to a different room. Let me go to the next slide. Tells you exactly how it works. Here's you have a control panel or any kind of you have a sampling ports that detects any kind of just detects any kind of smoke that it goes to your controller. In this case, it's a telephone equipment room, but it also applies to all the electrical equipment. And the way it works is a typical Vestas system. Here you can see the sampling points. You have this small sampling. All the air just goes to the sampling points and analyzes into your detection system analyzes. So their system are drawn into the sampling pipe and carries to the detected by the aspirator. And here's a slide showing how the aspirator works. Aspirator is just here's the aspirator has a fan and has a filtration system that it detects, and it has a detector. So it detects and sends a signal, hey, there's something wrong with the air. So that's what they shut down or whatever they have to do to control the problem. Advantage of aspiration system is no wiring, can be used in any environment, no radio frequency or magnetic problem, no maintenance of pipe network, good for high areas. Advantage aspirating system, okay, that'll be right. And this is the other type of laser type detector, they call it point detectors. Uses extremely bright controller laser diode. Light is transmitted to the chamber to a light trap. When the light is scattered, smoke, the light reflects off the mirror to the photodiode. Note that the light beam does not touch chamber surface. That's a point, they call it point detectors. That's a new thing in the market these days. Few applications, computer rooms, electrical rooms, clean rooms, cable rooms, hospital, historic site, museum, telephone switching station. Those are the ones lately they're using these units. Advantage of point system can be very economical if used with other addressable detection devices. Can pinpoint the problem, and programming by detector point can be used. Flexible installation. Application avoid with the view detector. Areas where cigarette smoke is present, you don't want to use those. Cooking furnaces, cooking fumes, condensed water vapor, steam or fog, high level of airborne dust, motor vehicle exhaust, welding or other process that causes airborne particles. You don't use this type. Other common fire detection system, we use heat detectors. Heat detectors normally used in areas that generates a lot of heat. We put those heat detectors. Advantage immune to false alarm in most cases. Disadvantage slow detection. Indoor application only. Fire must be near the detector. Image processing. There's a CCTV. This is what lately we use as a closed circuit TV. Its advantage is the potential for fast and reliable detection and ability to identify the location. Disadvantage of technology is early development stage. Not anymore. This is when it was developed. This was probably years ago. Now it's pretty good system now. The technology has been advanced already. Expensive, has problem. Yeah, that's true. It's very expensive. Just one CCTV costs like $3,500. Radiation, that's your flame detectors. Advantages, fast detection of fire in large areas, suitable for outdoor application. We put flame detector everywhere in our modules. Disadvantages, need line of sight, moderate cost, false alarm problem in older models. Here's the flame detectors, typical. And this is UV-IR. It kind of tells you UV-IR detectors, only if both UV-IR channels detect fires. Advantages are immune to heat and light source, especially if there's a welding, so you don't want to use that. UV-IR is we don't use UV-IR anymore. Basically, IR detector is a better way of going about. And the best one that we use lately is triple IR. Detects if the intensity of fluctuating radiation of 4.3 micron and the ratios between the intensity and that of a surrounding wave band of a 4 or 5 micron are all greater than a given given threshold. Advantages: completely immune to sunlight, background environment, all heat and light sources, arc welding, and lighting detection range give it 4 times greater than UV-IR. That's why we use this one. It's very sensitive, and we have used everywhere in our modules. Disadvantages are also as long range setting. The detector is sensitive to small nearby friendly fire, including flux burning and arc welding. Again, this is different type. We got the UV detector, and we have UV-IR. This just tells you exactly each category, what they can do. Triple IR detection, that's the one we are using, is a triple IR detection up to 50 meters. Some of it can go as high as 100 meters. So that UV-IR detector can see 100 meters. Just a small fire can detect. And that's why we have this corner. But you have to be light of sight. You have to be very clear. If you have any kind of a blockage in front, obviously it's not going to see it. So we do provide flame detectors every corner of the module. We do have it on top, bottom, all over. This is your CCTV. That's your closed circuit TV flame detector we use. And this one is those heat detectors we used just for the heat generating equipment. So, and that's this one. I think we time to maybe take a break. Maybe we'll come back. We'll continue. And I have also another